Hi everyone, today I'm going to show you some part of result of my work. The title of presentation is the formation of active copper cluster in Java size by co-synthesis. And the motivation of this work is to develop the copper containing Java size for the oxidation of methane to methanol by using different method like co-synthesis. The copper supersized sample was prepared by co-synthesis, also known as one-part hydrothermal synthesis. After that, the sample was tested at several conditions, then it was characterized by several techniques. This slide shows the images of copper supersized sample after hydrothermal synthesis. As you can clearly see the increasing of crystallinity with time and the increasing of the copper aluminum ratio with synthesis time. For the sample with lower SAR value of 12 and 6, they were prepared at longer synthesis time as well of 15 and 21 days. And we can observe the changing in color of the sample. And the reddish particle here that you can see might suggest the reduction of copper 2 to copper 1 and the precipitation of cuprous oxide. By comparing the XRD pattern of all the sample, XRD confirmed the formation of Chabasai zeolite. However, we observed the phase transformation in the sample uh, synthesized for 21 days. Also, no cupric or cuprous oxide are observed, suggesting a well dispersion of nano copper oxide, or it could be also the inexistence of copper oxide in the sample. The reducibility of the sample depends on SAR, depend on copper aluminum ratio and synthesis conditions. The TPR results show a higher reducibility of the sample with SAR 10.9, copper aluminum ratio 0.38, and PPR for 7 days. This sample also show a higher intensity of the reduction of active dimer copper cluster. So this sample has a higher activity by producing up to 112 micromole per gram per hour. Moreover, without calcination and activation before the reaction, the sample can produce up to 60 micromole methanol per gram catalyst and per hour, which is interesting, and we will find more evidence to explain about it. For the effects of copper contents and SAR, by comparing the methanol yields obtained from the same catalytic activity condition, the results show that the copper content doesn't strongly influence the catalytic activity of the sample with SAR 10 to 11, but with the SAR 7 to 8, the copper contents seem to increase the catalytic activity of the sample, and also the city of this sample seems suitable for the reaction under isothermal condition after activation with both oxygen and carbon dioxide. In conclusion, the sample with SAR 10.9 and copper aluminum ratio of 0.38 and synthesized for 7 days has a higher activity. This can explain by a higher reducibility of the sample itself and by a preferential formation of active copper dimeric cluster in 8-member ring.